All right, let's look at E12. It says during a hammer throw at a track meet, an 8-kilogram hammer, so our given and our find. So the mass of the hammer is equal to 8 kilograms. Is accidentally thrown straight up. So if we want to see a picture, here's our ground, which we call base level, and the hammer is thrown straight up. If 784 joules of work were done on the hammer to give it this vertical velocity, how high will it rise? So we want to find H. So they tell us the work is 784. So what do we do with this? So this is, remember, I know that the potential energy is equal to mgh, and I know work is equal to the change in energy, which is also equal to SD. So what I'm going to do is, remember, work is equal to the change in energy, and potential energy is mgh. So I'm going to set these equal to each other. So I'm going to say that mgh is equal to FD, and I want to solve for H. So I'm going to leave the H where it is. And what I'm going to do is, because it's in the numerator on one side of the equal sign all by itself. So now I'm just going to take the FD and I'm going to move the M and the G to the other side, which means I'm going to put them in the bottom. So H is equal to FD over mg. So now FD is my work. So I didn't really have to write that. I could have just done this and said work is equal to the change in energy. So this was 784 joules divided by the mass times gravity. So my final answer for the height comes out to be 10 meters. All right, let's look at number 13. So we're going to write our given, and we're going to write our find. So it says a 10 kilograms, so that's my mass. Remember, I'm going to chunk, I'm going to read, I'm going to write. It's fired vertically from Kennedy Space Center. Its fuel gives it a kinetic energy of 1960 joules before it leaves the pad. So the kinetic energy is equal to 1960 joules. How high will the rocket go? So I want to find H. So I'm going to do the same thing as before, but here, even though I'm going to be using conservation of energy, at this point, when something's going straight up, I know that the total energy at the bottom is going to be equal to the total energy at the top. Now, if I want, I can write the whole statement for conservation of energy, and I can say the total energy before, which would be at the bottom, would be the total energy after, which would be the top. So remember, this is the bottom, and this is the top. So the total energy at the bottom, I'm going to say KEI plus PEI is equal to KEF plus PEF. So at the bottom, my potential energy is 0, so it's kinetic. And then at the top, when it, we're going to see that, because it's going straight up, is equal to the potential energy at mgh. So we know that KEI is equal to the change in the potential energy. So if I say we already know this in our given. So I could say KEI is equal to mgh. And I think I want to solve for h. So I'm just going to rearrange the equation and say h is equal to KEI over mg. So it's going to be 1960 divided by the mass, which is 10, times gravity. So it comes out to be 20. So that's 20. So you see, like 12, 13, 14, sometimes you don't need to write this whole conservation of energy. So E14 says, and we'll write our given and find, a skater on a frozen pond pushes a 5-kilogram log, so the mass is equal to 5 kilograms. Let me push this up. To clear the skating area, if the skater does 600 joules of work, on the log and pushing it, what speed does it give the log? So we want to find VF. So I know that kinetic energy is equal to 1/2 mv squared, and this is going to be my VF. I also know that work is equal to FD, and I know that work is equal to the change in energy. So I can say that kinetic energy is 1/2 mv squared, and that work is equal to the change in energy. So when I rearrange that, I can say that VF is equal to, and I can do it if I want step at a time. So I can say, because we want to solve for VF, so I could say 2KE is equal to mVF squared. So 2KE over m is equal to VF. So 2KE over m square root is equal to VF. And then I can go back and solve it. But we can see every single intermediate algebra step so we don't make a mistake. So VF is equal to the square root of 2KE over m. So that's equal to 2 times 600 over 5. So 1200 divided by 5, and then the square root my calculator stopped working. And then we get our answer for VF.